Hello and welcome to my Marathos Atlas project, which is a Databricks data engineering project focusing on marathon performance analytics and data. The goal of the project is to build a complete ETL data pipeline from the raw to the silver one big to the bronze and silver layer of one big table, all the way creating to different dimension tables and all the way to the gold layer with the view tables. And then later using these view tables as a curated data for dashboarding and Genie space in Databricks. So to be able to do this project, we needed to use a Lakeflow pipeline with the bronze, silver, and gold architecture. We used PySpark transformations. We also created the gold views table, a published dashboard, and a scheduled pipeline. And then lastly is a Genie Assistant for user questions about the dataset. So the main dataset is a large marathon running dataset, which has a row representing one athlete, one result in one race. The dataset contains event information such as event name, date, the distance, finishers, and the performance type. It also contains athlete information such as ID, the athlete ID, gender, age, category, year of birth, the athlete country, performance result, and the average speed. One important concept to remember is that a race result record is not the same as a unique athlete. If the same athlete joins, for example, 5 races, then that will create 5 race result records, but only one unique athlete who ran the race. I also added a country reference data, so athlete country codes could be standardized and connected to readable country names. So this made it possible to create the country dimension and the filters and the global leaderboards and the country trend analysis later in the dashboard. My pipeline follows a bronze, silver, and gold architecture. The transformations are written using PySpark and Databricks Lakeflow. And PySpark is used because the dataset is large and it's designed for distributed data processing better. So in the bronze layer, I ingested the raw marathon dataset and the raw country reference. I used streaming table logic in the pipeline. This means the bronze and silver layer are designed to process incoming data incrementally instead of only working as a one-time batch job. So if a new marathon data is added later, the pipeline can continue processing it through the same architecture. In the silver layer, I clean and standardize the data using PySpark data frame. And this includes renaming columns to snake case, parsing event dates, which I deleted because it was an error, but I tried. Cleaning race distance formats, standardizing speed to kilometers per hour, validating the athlete age, handling missing gender and age category values, and joining the country reference data, etc. So silver layer is where most data quality work and cleaning happens. Invalid, null, unsupported, unstandardized records are filtered out, so the gold layer is more reliable. Another important part of the code structure is the utils folder. I use this to make the project more dry, which means don't repeat yourself. So an example script is the column helpers.py. Created reusable functions for column name cleaning. For example, raw columns can be converted into snake case format. So this keeps the column name consistent and easier to use in PySpark. Another example is the table name script, which centralizes the catalog, schema table, and view names. Instead of like hard coding, for example, the whole path or other table names many times across the project, I just define them once and reuse this table name util helper. Another utils that I use is a silver constant script, which is for repeated values in the silver layer. So it does the conversion of factors, is the speed limits, the age validation rules, hash settings, and unknown values. And then in the gold layer, I created a dimensional model with this four-dimensional model and one fact table. I have dimensions for event, athlete, country, date, and one fact table for the race results. Then after creating the view tables, this will be used later for dashboarding in the Genie chatbot. At the top, I have a race year filter and an athlete country filter. So these filters affect the KPI cards and most charts in the dashboard. So the focus will be on a specific year, and then can also choose the country. We can just try Sweden, or you can also choose several countries as well. But for this time, I'm only going to choose one country and one year. KPI cards show total race results, yearly unique athletes, countries represented, the average speed in kilometers per hour, the average athlete age, and the number of events held. There is another filter called leaderboard metric. So it is this leaderboard metric filter is connected to this horizontal bar chart right here, and it only affects this chart. The race year filter also affects this, but the athlete country filter does not, because this chart is meant to compare countries against each other. Next is the time series chart. For example, is the athlete's number of entries over time. Another sample is the number of events held, the average speed of an athlete over time, how the athlete age group has changed, and the average speed by age group. And all of these dashboards, or all of these graphs, are being influenced by the race year and the country filter. The competition category section compares kilometer races, miles races, and time races. The gender chart shows runner participation by gender. It also reacts to race year and athlete country filters. And then lastly, the runner demographic section, which is these two graphs right here, show number of athletes by age group and average speed by age group. So, and also the average athlete age over time as well in that specific year, in that specific country. So the pipeline is scheduled to run once per day. I did it at 8 a.m. Yes, just to continue about checking Genie's results. So I have asked the question, which country has the most race result records overall? Genie gave me the answer, the US, with 1.359656, and I validated it. This is proof that I validated it in my notebook, and it does say 1,359,656. And another question that I asked Genie is that, what is the year that Sweden had the most marathon events held? Athlete runner in 2019 alone. It gave me 521 events were held. Checking it in the Jupyter notebook again, and it does 521 in 2019 in Sweden. So I have created this new CSV and placed it inside the raw data catalog. I have ran my pipeline, and then after running my pipeline, I validated that new data inside my explorations in my notebook. The bronze code reads from the base directory, the path which is inside the data folder. So it was being read. And then I checked in the notebook in the bronze layer to see if it was also ingested properly. And yes, it is exactly the format that I have created for silver layer to be cleaned or to be placed into one big table. Dates are parsed, the event name are kept. They also kept the distance, standardized the country codes and the names, and I also kept the gender here, and I also passed the data quality filters. So I went into the gold layer that reaches the business model. So I should check that yes, and the goal validation should return two race result records. So this proves that the fake events data did reach the gold layer in the fact results in the other dimensional tables as well. In conclusion, the fake CSV passed through the transformation when I uploaded it into the raw data folder, and I ran the Lakeflow pipeline. And then I also confirmed this by checking the same fake events in bronze, silver, and gold layer. Is that I have refreshed my dashboard, and we should expect that since the fake data is from 2024 here, before it was only until 2022, now we should show at these three countries, Japan, Sweden, and France, showing up in my global leaderboard, countries represented, everything is 6. Yes, everything in the KPI cards are correct. So that was a proof that the streaming was working.